So hey guys, yesterday I talked about in the last video I talked about the RR case. So today I'll be talking about the LR case. So what is LR case? But before this, you have, to understand this, you have to watch the previous videos because I have built the momentum from the previous videos, like what is the Avl tree, how the balancing works, what's the balancing factor, etc. So today's case is LR case. So let's say I have a tree like this, 30 and 10. So what is the balancing factor of these two nodes? The balancing factor of this node is 0 and this node is 1 minus 0, it is 1. So it is an Avl tree because the balancing factor of this node and the balancing factor of this node is in the range. So let's say I want to insert 20. So where I will insert the 20? Here I have 30, here I have 10, so the 20 will be here because it is less than 30 and greater than 10. So I will mark it with another color so it will be easier to understand. This is 20, this is the newly inserted node, this is 30. So let's calculate the balancing factor now. The balancing factor for this node will be 0, for this node will be 0 minus 1, which is minus 1, and for this node it will be height of the left subtree is 2 minus 0, it will be 2. Okay. So according to the rule, we know we have to traverse upwards from the newly inserted node to the node which has an abnormal balancing factor. So that's this 30 node. So what we did here, we are traversing from the newly inserted node towards the node which has the abnormal balancing factor, and then we will traverse downwards towards the newly inserted node and capture the two movements. This will be L and this will be R. So you can see this is an LR case. For LR case, what we will do is what is the rule for LR? Let me copy this one. For LR case, what will happen is like for LR case, this 10 has the problem in the right side. So this 10 will go into a left rotation. This will happen first. And then this 30 has a problem in left side. So it will go in right rotation. So this will happen in the next part. So what's the resultant we are getting? If 10 is rotated this side, it will be 30, 20 and 10. Then we rotate this 30 only. So what we are getting, it's 20, 30 and 10. So we can see the tree is balanced. Like this has a balancing factor of 0, this has a balancing factor of 0, this has a balancing factor of 0. So you can see this is how an LR case is solved. Okay, so let's see how to code the LR. Let's say we have this C, this B and A, and we have this T1, this T4, this T2, T3. For LR case, let's Let's say we inserted a node n in either T2 or T3. Okay, so I have inserted a node here. So for inserting this node, let's say I have created a abnormal balancing factor in C. So now C has an abnormal balancing factor. So let's say how we find it, like we will traverse upwards from the newly inserted node towards the node which has a abnormal balancing factor. So I have reached C. C has a balancing factor of like abnormal balancing factor. Let's say 5 6 minus 5. It doesn't matter. It has a like abnormal balancing factor. So I will traverse downwards from C and capture the first two movements. It is L. This is R. So this is a LR case. So we can see this is a LR case. So how to find out this LR case programmatically? So this A will go in a this B will go in a left rotation. This will happen first, and this C will go in a right rotation. This will happen second, because B has a problem in right, so B will go in the left rotation, but C has a problem in the right, so C will go in the right rotation. So what will happen is, like, I will send B first. I will send B, like I will like this, like left rotate. Let's say left rotate is a function B, and it returns the node. Like after rotation, A will come here, so I will get the node. A node will be written, like the node which will be the new root node. So I can see if I send B, like I have sent B is here, T1, A, T2, T3. Okay, so I have sent this node, let's say, as B is the root node. So I want B to be left rotated. So we know how left rotation works, right? B will be left rotated. So we know how left rotation works. Left rotation is will be working like, just a minute. Yeah, we will send B node and this will be left rotated. So A will become the root node. B will come here. T1, T2. A will go here. So A will have T2, T3. B is less than, sorry, B is greater than T2 and T3. So just a minute. A is greater than B. So A will go here. B is smaller. So B will go here. A will go here. A will have T3. B will have T1, T2. Yeah, it's done. So let's check if everything is right or not. So A is greater than B. So A can go here. B is smaller than A, so B comes here. T is also smaller than A. T1 comes here. T2 is smaller than A, so T2 comes here, and T3. And the eighth node is returned here. So what's the resultant node we get after left rotation? The result, sorry, resultant node after left rotation is A. This is returned to us. Okay, so let me copy this. This is the first step. So A is returned and we have C like this. Here will come C. C has a node T4. Now this C will go in a left rotation and the root node will be returned. Sorry, the right rotation and the left node. So the code will be like this. Right rotate C. Will pass the Cth node. This is the second step. So if I rotate right, so A will become the root node, B will come here, C will come here, A is greater than T3 and also smaller than C, so T3 will come here, T4 will be here, B will have T1, T2. So now it is solved. So you can see we have solved it. Am I right? C, A will be, C is greater than A, C comes here, T4 is older than there, T3 is greater than A but smaller than C, so it's come here. We have like we have balanced the tree right now. So this is how we can solve the LR case. We can, this function which is here, let me highlight this one, and this one. We can use it from the like previous single left and right. This is for the left case. We will single right rotation, so C will go in a single right rotation. So we can reuse the function which we have written for the LL and RR case. So we can like use these two from that case. We don't have to write again. And also have to recalculate the height of the C and B. Yeah. This is the LR case.